Welcome to this presentation on the Newton-Raphson method. Today we will explore this powerful technique for root finding, its history, how it works, and its application in various fields. Let's dive in. Before we get into the details of Newton-Raphson method, let's briefly talk about numerical analysis. Numerical analysis is a field of mathematics that focuses on developing methods to find approximate solutions to mathematical problems. These methods are essential when exact solutions are difficult or impossible to obtain. One of the most important problems in numerical analysis is root finding, determining where a function equals 0. This is where the Newton-Raphson method plays a crucial role. It is an efficient iterative method used to approximate the roots of real-valued functions. Now let's take a look at the key contributors to this method. The Newton-Raphson method is named after two brilliant mathematicians, Isaac Newton and Joseph Raphson. Isaac Newton, known for his groundbreaking contributions to physics and calculus, originally introduced this method in the context of solving equations in his work on fluxions. And Joseph Raphson, an English mathematician, later refined and simplified Newton's approach, making it more accessible for practical use. His improvements allowed the method to be applied more easily without the need for repeated differentiation, actually. Thanks to their work, we now have one of the most widely used numerical methods for root finding. So let's see how it works. The Newton-Raphson method is based on the idea of using tangent lines like this to iteratively improve an estimate of a function's root. So let's consider this diagram. You know the definition of the first derivative of a function at a certain point like x0. Actually, the definition of first derivative of the function in the certain point like x0 equals to the delta y to delta x, delta y and delta x. So if we reshape this equation a bit, we can find this equation. Now we can calculate the x1 from this equation. Now, if we repeat this calculations for the other roots, we can get close to the main root. However, finally in this equation, xn represents the current approximation. The f of xn is a function value at the point xn, and the f prime xn is the derivative of the function. By applying this formula repeatedly, we get closer to the actual root or main root of the function. We can see the progress of the Newton-Raphson method in this animation more clear. You can see the closing to the actual root by the iteration of the Newton-Raphson method. So let's consider the Newton-Raphson algorithm step by step. At first, we start with the initial guess x0, and then we calculate the function value f of x of 0 and its derivative at the x of 0 point, x0 point. So I can apply the formula to get the next approximation x1 or x new, and we should repeat the process until approximation converges to the actual root. So we can define the threshold for our process, and this algorithm and process repeats until this condition satisfies. Um, so the Newton-Raphson method is widely used across various fields, including engineering, computer science, finance, physics and chemistry, and especially robotics and AI. So in the next video, we will solve a simple problem related to root finding using MATLAB. For more information, you can refer to this book written by Erwin Kreising on the chapter 19. Thanks for your watching. If you find this video helpful, don't forget to like, subscribe and share it.